All right, hey again, Honors Chemistry. So now we're going to look at question number 3, which is a bit more tougher. It has a lot of different variables in there. So it says a small bubble rises from the bottom of a lake where the temperature is 8 degrees Celsius and the pressure is 6.4 atmospheres. So I got a pressure and a temperature. To the water surface where the temperature is 25 degrees Celsius and the pressure is 1 atmosphere. So I have temperature, pressure, temperature, pressure. Calculate the final volume of the bubble if its initial volume was 2.1 milliliters. So now I have pressure, volume, and temperature variables in this question. The only equation that I could use all three of them is this combined gas law. So I'm going to write that down as the equation that I'm going to use. P1 V1 over T1 equals P2 V2 over T2. Now let me make sure I could sift out this information. P1 is 6.4 atmospheres. It says that's originally where it's 6.4 atmospheres. T1 was 8 degrees Celsius. But remember, we need to use Kelvin. So that's going to be 281 Kelvin. V1 was given at the very end of the problem. It says the initial volume is 2.1 milliliters. Okay. P2 is 1 atmosphere. T2 is 25 degrees Celsius, which is equal to 298 Kelvin. I add 273 to that. And then V2, I don't know. All right, and I'm going to stress and say again, to go from degrees Celsius to Kelvin, you add 273. I did not show it in this video. It's a very quick and simple calculation, but I showed it like quickly here. If I want to go from degrees Celsius to Kelvin, I add 273. And so now all I'm doing is plugging and chugging all of these values into this equation. So P1 is 6.4 atmospheres times V1, which is 2.1 atmospheres, over T1, which is 281 Kelvin, which equals P2, which is 1 atmosphere, times V2, which I don't know, all over T2, which is 298 Kelvin. What I would do is combine all the terms on this side. So if I do 6.4 times 2.1 divided by 28, 281, I will get 0.0478 on this side if I combine all of these terms. So I did 6.4 times 2.1 over 281. I get 0.0478. And then if I do 1 over 298, because I don't know what V2 is, I'll do 1 over 298. I'll get 0.00336 V2. Right, so what I did was I just combined the numbers. I could do 1 divided by 298. If there was two numbers up here, I could do 1 times that number and then have like an unknown on the bottom and then solve later, right? And then now that I have these numbers, I want to try and isolate this V2 by itself. So I divide both sides by 0.00336. And I know my volume is going to have the units of milliliters because I started with milliliters. So my V2 will end up being 14.23 milliliters. Okay, again, if you have another way of trying to solve for V2 by itself, you could go ahead and do that, maybe multiplying by 298 and then dividing by 1 and then V2's by itself. I just combine all my terms with multiplication and division. All right, so I just walked us through all the first 3 questions, and hopefully number 3 is a little bit more unpacked for you to try and do.